Good morning. Today we are going to cover 3.5 functions. So you should have your materials ready. The only thing that you need is your pencil, your ruler, your red pen, and last but not least, your highlighter. So let's get started. Remember that we're going to start on the left hand side and then we're going to continue on the right. So this one should be shorter lessons because we saved the shorter lesson for last. First, let's go make our left column. Um, 2, 4, 6. 6 spaces should be sufficient for us. And just make a line all the way through and making sure that you're using a ruler. I usually prefer the smaller ruler. Makes it a bit easier, at least for me. And the title for the lesson will be section 3.5. And I should make myself smaller so that I don't get in your way. Let's try. Interesting. Let's see if I can fix it. There we go. Much better. Correct. So let's go and write down the table of contents. Or table of contents will be section 3.5. Section 3.5 functions. So we talked about functions back on section 3.1, and we talked about functions. We plug in values for functions, and then we were able to graph them. We graph functions in 3.3. So today we're going to continue talking about what is a function. First, we're going to talk about what is a relation. And you don't need any cutouts for this section. I'm kind of flooring about what's going on with me yesterday. Much better. You don't need any cutouts. It's going to be a quick lesson. So we have a relation. So let's write down the definition. A relation is any parent of a set of inputs Now, do you remember which one is the input? Is the X or the Y the input? Correct. The input is the X value. So the X's. So each X, all the inputs are going to be paired up with a set of outputs. And therefore, the outputs will be, if your inputs are your X values, your outputs will be the Y values. Now, we have represented relations since section 3.1 in several ways. But we haven't used mapping before, so that'll be something new for you guys to see. Mapping. We can represent a relation as a mapping. So just careful, let's go and draw the map. It's going to be a bubble here. So let's go and write down the numbers first. We might make it a bit easier. We have a -3, we have a 1, we have a 2, and we have a 4. And we're going to place a little bubble around it. So it's going to be like a little oval. Then we want to skip 2 lines and now two spaces. And now I'm going to write down another set of numbers. So it'll be -2, -1, and +3. And notice that I skipped the space in there. And now I'm going to place another bubble. So this is considered a mapping. Now with my red pen, I'm going to place my pairing. I'm going to pair my -3. I'm going to pair it with my -2. I'm going to pair my 1 with my -1. I'm going to pair the 2 with the -1. And last, I'm going to pair the 4 with the 3. So that's called a mapping. Now, whenever you see a mapping, this is going to be represented as a table of values, or we can also represent them as a point. So as a table of values, I'm going to make it table. I should have left a little more space. I need 4, so this should be sufficient. So therefore, we are going to have your table values, what we did on section 3.1. We are going to have x values will be your input, and y values will be your output. So you might want to just highlight that part because that is something that you need to memorize. Your inputs and your outputs. If you guys remember, we've been plugging in numbers for x, it will give us back values for y. So now, this represents a set of points. The -3 is paired up with the -2. This is your input. X, Y are your outputs. And now we can write them down as a table of values. The -3 is paired up with the -2. The 1 is paired up with the -1. The 2 is also paired up with the -1. So therefore, we get another point. And the 4 is being paired up with the 3. So therefore, this mapping can be translated as a table of values. And this table of values will represent points, and we call them order points. So the order points are going to be -3, -2, 1, -1, 2, -1, and the last one will be 4, 3. And now on the space that we have left is going to be a graph. So finally, this can be represented as a graph. And I'll make a, let's see, do we have space for 10? No, but we do have space for a 4 by 4. So therefore, I'll place from here 2, 4, halfway mark, 2, 4. And that should give you enough space. If not, you can do it right underneath. It's fine. I'll go up 4 and down 4. So therefore, the mapping can be translated into a table of values. The table of values can be translated into points. And your points can be translated as a set of points. So -3, and we can plot them -2. We go to the right 1 and down 1. We go to the right 2 and down 1. And last, we go to the right 4 and up 3. And that is perfect. So therefore, a mapping can be translated as a set of values, which can be translated as a order points, or order pairs, we usually call them, not points, but they're points, right? And they can be plotted on a graph where we have your x values, your x-axis, and your y-axis, the same way that we have your x values and your y values. Now, let's go over the definition. What is a function? So a relation, so right underneath, we're going to write down the definition. We're going to say just make sure that you see this line. So I'm going to make sure that I follow. And therefore, I'm going to go one below it, so I have enough space. And now we have enough space to write things down. Now, sometimes my computer freezes a bit. So let me go and make it and see if I can fix that for us. And back again. So we have a relation that pairs each point with one output, or not each point, but each input with one output. So every time that we are able to pair up each input with exactly one output, is a function. So therefore, the proper definition of a function is a relation that pairs each input with one output. And the keyword is one output. So therefore, let's look at some examples. Example number one. And then we can talk about a few things that are relations, that are also functions, and a few relations that are not functions. So the way that I think about it is, it functions, does it function or does it not function? So that's something to keep in mind. The actual word will tell you. And we'll go through a specific example so you can remember. Example number one. It says, decide whether each relation is a function. So therefore, for each one, we're going to write down it is a function or it's not a function. So for letter A, and we're going to have A, B, C, D, and E, and maybe F. A. On letter A, we are going to write down a set, and we're going to place a little brace, a squiggly brace, or what people call a fancy brace. And then in each one, we're going to have a set of points. We have a -3, 0. Then we have a -4, 0. Then we have another point that is 3, 2. And finally, we have another point that is 2, -4. And then we're going to place another brace here to close it up. Now, usually we place commas in between. So I just place my commas in red. So that way I don't get them confused with anything else. Letter B. And we're going to place letter B right next to it. And that'll be, this is set M. So what's after M? N. And you can place any letter as a set. Notice that the set notation we usually place as an uppercase. So the next one is 2, 3. We have 2, 5. We have 3, 7. And the last one that we have is -4, 0. Then we're going to close or brace. And then we're going to place commas in between. So we use this type of notation in pre-calculus and in algebra 2. We have just the braces, basically just a group of points. So therefore, I need to go to decide if this is a function and if that's a function. Now, they both are relations because each of them is pairing an x with a y. But the difference is that whenever it's a function, each input can only be paired with one output. And the way that you can remember is that the x values cannot be repeated. So let's look at the first one. So we're going to highlight, or let's go and circle in red. Might be easier to read. Sometimes the highlighting comes as a pencil, correct? So let's go and circle with your red pen. Let's go and circle the x values. Are any of the x's being repeated? And you might say, Yes, we have a 3 and a negative 3. Well, they're different numbers, so those are not repeated. That doesn't count. So are any of the x's repeated? No. So therefore, it is a function. So we're going to say function. And you might want to just underline it or just circle it. That is your answer. Let's look at the second one. We are going to circle your x values. And by circling your x values, you are able to remember the process. Your brain has to work not as hard to remember things. So therefore, is that a function? Yes or no? Well, let's look at the x's. Do any of the x's repeat? Yes, they do. We have the 2 here, and we have another 2. So therefore, the way that you want to think about is that we cannot plug in a 2 and get a 3 the first time, then plug in a 2 and then get a 5. So let's go through an example. So let's say that we have Mike and Mary. So we have Mike and Mary. And their teachers gave them a problem. They gave them the equation y equals to 2x plus 1. And they asked Mary, they asked Mike to plug in a x is equal to 2. And they asked Mary, x is equal to 2. So therefore Mike says, well, I'm going to do it in my head. I'm just going to do the work. And he says, if I plug in a 2, I end up with a 3. And Mary says, hold on. If I plug in a 2, I end up with a 5. So the question is, can they both be correct? What do you think? Is that a yes or a no? Can both of them plug in a 2, but they get different numbers? Well, that can't be right. Who's right? If you plug in a 2, you end up with a 5. Mary is correct. So therefore, that is why this is not a function. You cannot plug in a 2 and get a 3 the first time, then plug in a 2 and end up with a 5. That makes no sense. That can't happen. So therefore, that is not a function. And I want you guys to underline the word not. And that is what we're doing today. So it's a very simple lesson. But on the left-hand side, we are going to write down x values cannot repeat. So x values cannot repeat. Because if they do repeat, then that is not a function. Make sure that you highlight it, or let's go and place a little bubble around it. I'll use my other highlighter to place a little bubble, and that way I know that I need to remember this. X values cannot repeat. Then if they do repeat, then that is not a function. If they do not repeat, then it is a function. So let's try letters C and D. For C and D, we are going to have a mapping. Mappings, actually, I kind of like to draw them. I prefer to place my numbers first. And I'll skip 2 lines and 2 and 4. And I'll place a little bubble in here. That is the first one. And that is the second. And now the way that these ones are paired up is that the 1 is paired with the 2. And the negative 2 is paired with the 4. Then the 3 is also paired with the 4. Let's go and draw the second one, and then we can decide whether they're functions or not. So for the second one, I have a negative 4 and a negative 2. And now I must skip 2 lines, and I have a 1, a 3, and a 7. Now I'll place my bubbles on 1, then my bubble on the second. And now I'm going to do my parents. My parent is 1 and negative 4 and 1, -4 and 3, and 2 and -7. So those are the given problems. So that will be something that will be on your homework. And then you need to decide, is that a function? Yes or no? So if you need more time, go and pause it so you can draw them. So is this a function? Now sometimes it's hard to be able to decide if it's in that format. So what I usually do, I take the time to rewrite them as points because that makes it a bit easier for me. So let's go and do a point. So this is the 1 is being paired up with the 2. So therefore the 1 is being paired up with the 2. Easy as that. Now the -2 is being paired up with the 4. The -2 is being paired up with the 4. And now the 3 is being paired up with the 4. And I need to decide, is that a function? Yes or no? What do you think? It is a function, but because we are going to only circle the x values. So I'm going to circle the x values. Are the x's being repeated? No, they're all different. So therefore, it is a function. Next, is this one a function? So one way to find out, to decide if it's a function or not, is we're going to place them as points. So take the time to place them as points. You should end up with 3 points. 1, 2, and the way that I need to know that I have to end up with 3 points is because I have 3 arrows. If I have 4 arrows, then I'll have 4 points. 5 arrows, 5 points. 1 arrow, 1 point. So go and pause it, write them down, and then decide if it's a function, yes or no. So let's go and go through. You got it? At this point, you should have. So we have a -4 and 1. We have again a -4 and a 3. And last, we have a -2 and a 7. And now I need to decide, is that function yes or no? It is not a function. Why? So therefore, notice we have 2 -4s. So not a function. Should we try another one? Or is it good? So that's good, right? Now there's something else that we need to be able to cover. We need to be able to decide, talk about your domain and your range. So your domain, so let's go draw a line so we can actually, and we're just going to do A and B on the next page for domain and range. And then we just have the vertical line test. And then we'll continue talking about domain and range as well. Interesting. There. So your domain versus your range. So something that you need to be able to remember that in math, your domain are going to be your inputs. Your range are going to be your outputs. So therefore, your domain are your x values, and your range are your y values. And we're going to talk about your domain and range. So for example, if I was going to do this problem here, and I want to find my domain will be all the x's, -3, -4, 3, and 2. My range will be the y value, 0, 2, 0, -4. So let's do example number 2. Let's do our 6, 2, 4, 6. I'm going to do 7 on this side. We are going to find our domain, and then we're going to talk about your range. But before we do that, let's talk about vertical line tests, and that way we can do one example less. So we have what we call, and in this case, you don't have a cutout, so I'm just going to do a little box in here. I'll place 2 squares here. So 2, 4, 6, 8, 9, 10 squares. And we're going to do a quick graph in there. Then I'll go all the way to the side. So in case you don't have your cutouts with you, you can always do this. And I don't know what you're thinking, Diaz, where are my cutouts? I know. Somehow they just got cut off for this section. So we have vertical line test. So a vertical line test, so a graph represents a function when no vertical line passes through more than one point on the graph. And let's just go make it two. I'm gonna make 2 small graphs, very small, since I didn't leave enough space. I'm just gonna make it 2 by 2, and then I'm gonna make 3 graphs. You might have more space than I do. So there are going to be times that they're going to give you a set of points. And the points I'm going to place 1 here, 1 here, 1 here, and 1 up here. On the next one, I'm going to place 2 points here, 1 here, and 1 up here. So on each one, we have 4 points. On the last one, I'll place 1 point down here, 1 point here, 1 point down here, and the other one down. And I need to be able to decide whether they're functions or not. And the way that we're going to do this, you're going to get your red pen, and we're going to draw a vertical line. And then I must say, okay, how many times does the red line crosses? How many points does it cross? Only 1. So far, so good. And then I'll go to the next line and say, how many times does it cross? Once. Only 1 point. How about this one? Only 1. And this one? Only 1. So therefore, this one is fine. But for the second one, notice that if I make a vertical line, how many times does it cross? Twice. So therefore, that's not a function. And I can just stop, because I already know that there's not a function, so why bother? The next one, only once. So if you make a vertical line, it can only cross 1 time. So therefore, is that a function? Yeah, that one's fine. So the one that's not a function is the one that crosses twice. So let's try example number 3. Number 2. So we're going to say, find the domain and range. Find the domain and range. Then determine whether it's a function. And we're going to have A and B. Then we're going to do example number 3, and then we'll be done for today. A and B are going to be two graphs, and on the graphs, I'm just going to give you a set of points. So let's make a 5 by 5 graph. 2, 4, 5, 2, 4, 5. And I want to do the same thing for the next one. 2, 4, 5. I want to go from here, one more, from here all the way up to here. So sometimes I count them, sometimes I just know the size. And the points that we are going to have for the first one, so if you need more time, go and pause it, and that way you can take the time to draw the graphs. Make sure that you guys are using a ruler. Very important. The first point is here at -4 and +2. The second one is at 1 and 4. The next one is at 3 and 2. And the last one is at 1 and -3. So we have 4 points once again. So first, let's decide, is this a domain? Well, let's go and find the domain range first. That might be easier, right? So we're going to write down domain. And then we're going to find the range right underneath. And in this case, we're going to place it as a notation. What I'm going to do, I'm going to write down the point, the location of the points, and I'm going to write down on the left-hand side so I have more space. So I have 1, 2, 3, 4. So I have 1 point, 2 points, 3 points, 4 points. So go ahead and write them down and see what is the domain and what is the range. So let's see. Got it? So first, what is the domain? Well, no, what is the location of this point? -4 and up to. What is the location of this point? 1 and up 4. What is the location of this point? 1 and down 3. -3, right? And the last one will be to the right 3 and down 2. Because I went down, it will be negative. So now that you have the points written down, then we can find the domain and range very easy. So first, let's go and find the domain. Your domain are all your inputs. So therefore, I'll place DR, doctor. So that's a very easy way to be able to remember your domain range. Doctor. Domain are your X values. Your range are your Y values. So let's go and write them down. You always want to write them down from the smallest one to the largest one. So which is the smallest one of those 4? -4. Then we have a 1. If the number repeats twice, we just write them down once. And then the last one will be 3. And now your range. Your range are your Y values, which is 2. Well, we have a smaller number. Which is the smallest number that we have? Smaller number is -3. So we should write down the smallest one first. We have -3. Then which other one goes next? -2. Then 2. And last will be 4. And last, I need to decide whether this is a function or not. So what I'm going to do, I'm going to place vertical lines. Let's see. Let's say a line that's vertical. Only 1 point. So far, so good. I place a line that's vertical. Nope. So I can stop. Not a function. Make sure that you place it in red or circle or underline it to remember that that is not a function. We have letter B. We have 1 point here, 1 point here, another one here, another one here, and the last one is here. We have 5 points. So let's go and write down first our domain and your range. And we're going to write down what we call a set notation. And now let's go and write down all the points here. 1, 2, 3, 4, 5. Go and take the time to write them down and see what you get. So let's see, your domain. Your first point. This one is -3 and +3. This one here is -2 and +1. This one here is -1 and -1. This one here, your x value is 1, your y value is 1. And the last one is 3, 3. So I see a lot of 3s and a lot of 1s. But the question is this a function, yes or no? Then the second question is a domain and range. Let's do the domain and range. So we're going to go from the smallest one to the largest on the axis. And notice that because I start from here to here, I already have them in order. So -3, -2, -1, 1, and last will be 3. And now your range, which is the smaller number? -1. Then the next one, it's 1. We have 2 1s, so we just need to write them down once. And then 2 3s, I'm going to write them down once. So that is your domain and your range. Now I need to decide, is that function yes or no? What do you think? It is a function. But I do need to see all your red lines. So if I place a red line going through here, it only crosses 1 point. I do the next one, 1 point. The next one, 1 point. The next one. So they only have 1. And notice that even if we look over here, your x values do not repeat. Where on this one, your x value repeated. And that's why this one's not a function. You cannot plug in a 1 and get a 4, then plug in a 1 and get a -3. That cannot happen. So this one is a function. So happy face, sad face. And the last example for today, example number 3. On the next one, we're just going to determine whether they are functions or not. And we're going to make some nice graphs. Example number 3. Determine whether the graphs are a function. So I'm going to place 3 graphs. So therefore, I'm going to make them a little smaller. I'm going to place A, B, and C. So in this case, I'm just going to make 4 by 4s and see if I have enough space. 2, 4, 2, 4. That's my first one. I'll place a 4 by 4 right next to it. So 2, 4. So I'm going to leave 2 spaces in between. And the last one, I'm going to leave 2 spaces and see if I have enough space. I think that should be good. 2, 4, perfect. So now the graphs that we're going to do are going to be, the first one is going to be a nice oval. It's not a circle because the length is longer than the height. The next one that we're going to do is going to be a V. I'm going to start from here. I'll go straight. It doesn't really matter, but for now we're going to do a nice V. And then same thing for here. I'll follow the little grid. And that'll be. And for the last one, it's going to be a fancy U. So it's going to be 2. So just a u that's going to go all the way down. And now I need to determine whether those are functions or not. So first, if I make a vertical line, how many times does it cross? Twice. Once here and once here. So can that be a function? No. So not a function. Sad face. Then I'm going to draw vertical lines. Say, how many times does it cross? 1. I'm going to try again. How many times does it cross? Only once here. So every time if I make a vertical line, how many times does it cross? Only once. If I make another vertical line, it only crosses once, 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 once. If it only crosses every single line, only crosses once, so there is a function. How about for the last one? Last example for today. Is this a function? Yes. Notice that if I just make my vertical lines first, and then I kind of think about how many times this line crosses? Once here. How about this one? Only once. Over here, only once, once, and only once. So that one is a function. Questions. So we can determine a function in 2 different ways. We can look at the x values, and the x values cannot repeat. If they do repeat, it's not a function. Another way that we can determine if it's a function is to give you a graph. We can make the vertical line test, and I need to see those red lines on your homework. So have a great day. We'll practice this next time. I'll see you, and email me if you have any questions.